Hello and welcome to today's physics lecture wherein we shall be discussing about current and magnetism over here. Now today's present topic will be about that what a temporary magnet is and what a permanent magnet is, right? So first of all over here, let us discuss both of them at one go so that we can compare them. So let us say, for example, on the left hand side we are going to see about the temporary magnets and over here the permanent magnets. So here as temporary magnets and over here as permanent magnets. Now these temporary magnets, they are also better known as electromagnets, right? So the temporary magnets could also be termed as electromagnets. Now, to understand about a temporary magnet or a permanent magnet, there are some basic terms which we need to understand. Say for example, the retentivity, the coercivity, and the value of saturation of magnetization, right? Now, as we could understand by the word of retentivity, it means that if something is being applied on this, for how much amount of time can it retain what is being applied on it, right? So, for temporary magnets, we know that actually when the magnetization or the force of magnetization, when it is removed from it, actually it loses its magnetism, right? So we can say over here, the first point is that they have low retentivity. The low retentivity means that as soon as the magnetization force is being lifted from it, this kind of electromagnets, they stop working like a magnet, right? Their magnetic properties are vanished at that particular time. Whereas in the case of these permanent magnets, this is not the case. The permanent magnets are those that even if you are going to remove the magnetizing force, this will still retain its original behavior as a magnet, right? So, since it has low retentivity, we can say in permanent magnets that it has got high retentivity. Now, this retentivity actually depends somewhat like on the coercivity. Now, what coercivity is? Say for example, this is a magnet, irrespective of this temporary magnet or this permanent magnet, right? Say for example, if this is a bar magnet, now over here we are going to demagnetize it. So if we are going to provide only a small amount of work in order to demagnetize it, it will mean that it will be having low coercivity. While on the other hand, if we need to apply enormous work on this magnet so that its the magnetic properties are vanished, then we will be saying that it has got high coercivity. So we can understand from this that the temporary magnets or the electromagnets, they basically have low coercivity so that it could be easily demagnetized. So we can write it as low coercivity. And over here, since it is low coercivity, it will be high coercivity, because this will not easily demagnetized. So we can say it as high coercivity. Now, here comes the point of, okay, something is retaining, it has got high retentivity or low retentivity, whether it could be demagnetized very easily or not. But when we are going to actually magnetize it, right, we are going to see that whether or not actually this will be magnetized. If it is not magnetized easily, obviously it would not be a magnet. So in this case of either the temporary magnets or the electromagnets, or in this case of permanent magnets, both have high value of magnetization saturation, right? So we can state it as, the third point as, high value of magnetization saturation. Likewise, this will be the case for permanent magnets also, because otherwise we cannot even make a magnet, because if it does not have a high value of magnetization saturation, we cannot even make a bar magnet, right? So this also have high value of magnetization saturation. Now, as we have understood that what retentivity is and what coercivity is, what does actually the magnetization saturation means? The more the magnetization saturation value, the more strong magnet it will be. Say for example, a magnet has got this value of magnetization saturation as only 2, whereas the other magnet has got the same value as equivalent to 200. So it may be said that if in our vicinity, if both are placed and just in the middle of them, say for example we take it as, this is one magnet and this is another magnet. Now this value of magnetization saturation for this bar magnet is only equals to 2, whereas in this case this same value is equals to 200. Now say for example, if an iron nail is being placed as such over in this region, that this distance from this magnet, the distance of this iron nail from this magnet is equals to R, and same is the distance from this iron nail to the other bar magnet. So both are separated from this iron nail by the distance of R. Now this value of magnetization saturation actually determines that to where this iron nail shall go. Obviously, both will try to attract this iron nail, but unfortunately, there are two bar magnets. Both are bar magnets. So, the one which have a higher value of magnetization saturation will attract this iron nail towards it. Right? Now, the next point over here which may be noted is the hysteresis loss. Now, the hysteresis may be defined as the lagging of the magnetic induction B on any material to its magnetization intensity H, right? So over here we could say as the hysteresis loss in the case of temporary magnets or electromagnets must be small. Right? Now, why this is asked, why it is preferred that for a temporary magnet it should have a property that the hysteresis loss must be small. Because if and only if the hysteresis loss is small for this case, then during the period of magnetization and demagnetization, this particular magnet or this particular temporary magnet will not be heated up much, right? Now, for this, in the case of permanent magnet, we could say that the hysteresis loss actually does not count at all in this scenario. So, the hysteresis loss is basically not an issue for the scenario of permanent magnets. Now, why is this so? It may be noted that as hysteresis is defined as the lagging of B to H, or capital H, we could say that, for example, this is not a temporary magnet. So to make it a temporary magnet, we have to undergo the cycles of magnetization, demagnetization, magnetization and then demagnetization like this, right? But in the scenario of permanent magnets, this is permanent magnet. We need not to undergo the steps or the cycles of magnetization and demagnetization. So if we are actually not undergoing those cycles of magnetization and demagnetization in the case of a permanent magnet, so the hysteresis loss is basically not an issue in this case, right? The next point that could come up is like the examples. Like for these temporary magnets or electromagnets, we may state that these are like soft iron. And the soft iron, they are made temporary magnets or electromagnets in order to lift the ferromagnetic substances. The application is in order to lift ferromagnetic substances. Now the example of the practical application may be like the cranes, right? Now over there, actually, if you have a huge pile of iron, right? Say for example, the weight is measuring like millions of tons and it needed to be lifted up. Now, are you going to tie a string over that bundle of like huge pieces of iron? If you are going to tie up over there, and if you are going to hook it up and trying to lift it from one place to another, it may break down and could cause severe accident, or it could cause severe mishappenings. The best way for this is to use an electromagnet or a temporary magnet. Over there, when we push the button, actually what happens is that the soft iron which is been attached to the crane, to the point of the crane which is allowed to lift up, it gets into the cycles of magnetization and demagnetization, and it starts working as an electromagnet or a temporary magnet. Now that millions of tons of iron which is underneath lying on the ground, they could be easily lifted up, right? Because due to the property of attraction between the iron and the electromagnets or any kind of magnet. Now, as we have seen earlier, that iron basically is a ferromagnetic substance, so we may state that the soft iron, this is being used as an electromagnet in order to lift the ferromagnetic substances, right? Now, it may be noted that iron at a temperature higher than actually 770 degrees Celsius, it stops working like a ferromagnetic substance and starts working like a paramagnetic substance, right? Now, like this, we want to know that what could be the examples that what we could use the permanent magnet as. We could use steel in this case of a permanent magnet. But it may be noted that steel does not meet all these properties which are needed to be a permanent magnet, right? Say for example, the limitations are say number one, it does not have a high value of magnetization saturation. So we may write that over here, the point number 3 which we stated, it does not have that high value, right? But yes, the solution to this is that we could actually use the laminations over the steel, okay? So we may say that the solution is laminated steel, right? It may also be noted that the other limitations of the steel, as for example, what the other properties, actually it does not have that much. It has the properties, but not up to that level what is desired in the case of a permanent magnet, right? So the second one it is that it does not have a high, like say, retentivity or coercivity. So, in modern applications where it is highly desirable to design a perfect permanent magnet, we do not use the steel at all or the laminated steel at all. Because using the laminated steel, yes, it actually increases the strength of the magnet, because we know that if it is gaining a higher value of magnetization saturation due to this lamination, the strength of this like permanent magnet of steel will increase, but again we are not getting this retentivity and high coercivity. So nowadays the alloys have been found out which have got the high values of retentivity and high values of coercivity, and as well as they have the high value of magnetization saturation. Such alloys are like aluminium, alnico, etc. Right? Now, over here, then what is the purpose? As we have seen that what are the applications of a temporary or an electromagnet. Now, what is the basic application of a permanent magnet? The permanent magnets are actually, they are used in making measuring instruments which work on the principle of current and magnetism. Say for example, a very small application of a permanent magnet is the magnet's compass, right? Because, say for example, if you do not have a permanent magnet as the needle of that magnet's compass, you could not actually take it out from your pocket and see the North Pole or the South Pole direction, right? So the needle of a mariner's compass obviously needs to have a permanent magnet. So this is all about the electromagnets or the temporary magnets vis-a-vis with the permanent magnets, right? Thank you.